the Natural Resource Management session. That's Professor Hassan Mouri. So, Prof, the floor is yours.
Hello. Good morning, everyone. Thank you, Thomas, Prof. Thomas, for the introduction. I'm pleased to be here today to give this plenary lecture on the role of medical geology in achieving the UN SDGs. And I would like to thank the organizers for the opportunity and for inviting me to this event. Let me start by this quote. Since we are in a conference that is dealing with environment, earth and environmental science, I would like to share with you some insight into the impact of environment on health. And I start by the quotation of Dr. Davis, an American epidemiologist, who says, "The genes give us the guns and the environment pulls the trigger." What is this environment that we are talking about? The environment around us has direct or indirect impact on our health and the ecosystems in general. It forms part of the contributing factors to a number of non-communicable diseases that we know about. Therefore, it has a great impact on the socioeconomic development and therefore impact the achievement of the UN SDGs. This environment can be divided into two aspects: anthropogenic, which are all man-made, which I'm not going to talk about today, and then the geogenic, which forms the focus of my plenary. The geogenic factors are those related to the natural environment, processes and factors, including volcanic eruptions, earthquakes, weathering of rocks that are responsible for the formation of soil and dust. Both of them contribute to our health through accumulation of toxic elements in food crops, through soil, and then inhalable nanoparticles in the air through the dust particles. And then, of course, another parameter is the interaction of rocks and soil with water, which enables chemical elements to be leached into water and then reach our body. And finally, mining is a composite between anthropogenic and geogenic, because if there are no natural resources, there will be no mining. So that is why I put it under the two composed of anthropogenic and geogenic. So then what is medical geology? I'm sure you wonder, what is it about? It's a discipline that deals with the impact of the geological environment on our health, humans, animals, and ecosystems in general. It has either positive or negative impact depending on the composition and the concentrations of the elements, the chemical elements in the environment. And of course, I need to stress that in medical geology, we do not cure diseases, but we look for the sources or the causes of the disease. So medical geology is a multi-cross, interdisciplinary field of science that is bringing together geoscientists, environmental scientists, biologists, biochemists, toxicologists, epidemiologists, and so on. There is a room for anyone to be part of this discipline. What are the exposure pathways and control effects on health? The pathways include dermal, ingestion, drinking, breathing, inhaling substances in the environment. What are the control effects? Two main control effects: the exposure and the dose. I'm sure you know, from a toxicology point of view, that long-term exposure to low doses or low concentrations of toxic substances or elements in the environment has exactly the same effect to short-term exposure to high concentrations of the same substance. And the dose is too much of anything is too much. I always tell my students that the only thing that is not harmful to our health is studying. You can study as much as you can, it's never harmful. But anything else, too much of it is too much. So I hope there are students here who can apply this law of toxicology. So the optimum balance means that you need to have what is required for our health. We cannot just go to the pharmacy and buy supplements thinking if we take calcium, it will help us, or we take magnesium and so on. Because too much of anything can undermine the impact of other elements and so on. For example, too much of calcium prevents the uptake of magnesium. And then, of course, to all this, we have the bioavailability and bioaccessibility of elements. Now I move, after this short introduction about the medical geology, the definition and the controls, the impact on our health, I would like to give some examples on why do focus on Africa. Africa, from a geological point of view, those who are in geology in this room, they will agree with me that it is well studied to some extent from a geological evolution, geohazards processes, natural resources evaluation, and mining. These aspects are the main focus of study about Africa. However, what is lacking is the impact of this geo-environment on health. We have maps of mineral resources in Africa, we have a geological map, we have even age-standardized non-communicable diseases map, but we don't have a map that shows the relationship between the occurrence of toxic elements and minerals and health issues. So, from a geological point of view, Africa is characterized by a complex and dynamic geological evolution and history characterized by volcanic eruptions, earthquakes, dust storms, and all these, as I said at the beginning, they affect the air quality, water quality, and soil quality, and in turn, it affects the food quality. And these together affect our health. What is complicating the situation in Africa? Climate change and geomorphology, drought, large parts of Africa are arid or semi-arid or deficient in what we call essential elements which are required for the well-being. And this is due to the nature of the geological background. We have also, this geology has, or the drought has, impact on water quality. When there is a drought, there is a serious issue related to the uptake of essential elements by the food crops, because there is no water to stimulate the uptake of the chemical elements. Then we have floods. These are common on the African continent, and it affects our health in a way that it flushes the potential harmful elements that are found in a specific area, takes them into another area, and it contaminates the soil and the water aquifers. Or sometimes it's leaching of the essential elements that are required for our health. Sorry. What is complicating more the situation is the socioeconomic aspects of life in Africa. As you know, life is mostly in rural areas, factories and mines. People rely on locally produced food, untreated water, poor soil quality, and then in some parts of Africa, people consume soil, clay, and rocks, termed as geophagy. And then, of course, another element that complicates the situation is the limited access to efficient and fair health care service on the continent. And finally, of course, mining, whether it's active or closed, they always have impact on the geo-environment. From a health point of view, I would like to give a quick background on what is NCD. NCDs, or non-communicable diseases, are chronic conditions not caused by infection. They're related or caused by a combination of genetics, metabolic, behavior, and environmental factors, according to the World Health Organization. But under the environmental factors, you can see that we have outdoor and indoor air pollution, secondhand tobacco smoke, exposure to chemicals, radiations and noise, occupational risks. There's nothing about geo-environment. Amongst the most common non-communicable diseases that are causing death, the leading causes of death are cardiovascular diseases, chronic respiratory diseases, cancer, diabetes, plus mental health issues, which start to be an emerging issue. Over 80% of all premature deaths are actually related to or caused by NCDs. More than 15 million of people die from one of the NCDs or a combination. They are between the age of 30 and 69 per year. And the studies that took place so far, they focus mostly on risk factors and treatment of the symptoms rather than the causes of the disease. Therefore, there is a need for understanding of the leading cause from a geogenic perspective, which is missing so far. Looking at statistics, according to the World Health Organization reports, 77% of all non-communicable diseases causing deaths are occurring in low to middle income countries. Africa is one of them. And 80% of premature deaths are also occurring in low to middle income countries, which means Africa is one of them. Overall causes of death in 2021, you look, for example, globally, we have 27% related to communicable diseases. The rest, 63%, are all related to non-communicable diseases. This is globally. In Africa alone, 35% of deaths are caused by non-communicable diseases. So there is great concern about the impact or the occurrence of non-communicable diseases in Africa. For example, between 2010 and 2019, there is an increase of from 2.4 million to 2.8 million deaths in Africa, as you can see on this graph here. This laser, is it made in Africa? That's why it's not working. Sorry. Okay. As you can see there, about here in 2010 on the graph in the pink color, about 2.4 million. And in that corner there, you have the total number of 2.8, roughly, of deaths related to NCDs. And more than 50% are actually between the age of 30 and 70, and the leading causes of the deaths are cardiovascular, cancer, chronic respiratory disease, and diabetes. Keep in mind this trend we will see later when we look at some examples. So I looked at 2 cases, South Africa, where we are, and Algeria, which is my birth country. And from the reports of the World Health Organization, 56% of deaths are related to these 4 typical or common non-communicable diseases, and in South Africa, 40%. And if you look at the distribution of each of these 4 diseases, cardiovascular, cancer, diabetes, and chronic respiratory disease, you see the same trend. Cardiovascular is always the dominant or the leading cause, followed by cancer, and then the other diseases. Now, from an epidemiological point of view, I would like to illustrate with 2 elements, 2 cases of chemical elements. One is toxic, and the other one is essential to our health. Let me start with arsenic. Arsenic is a toxic element by definition, and according to the World Health Organization, the required or the daily recommended value or standard is 10 micrograms per liter. From a health point of view, arsenic was known to cause cancer. That's the most common or known disease. However, there's growing evidence that arsenic toxicity can lead to cardiovascular diseases, including respiratory diseases and diabetes. So it's not just cancer as we believed in the past. These pictures here are from arsenic toxicity in Bangladesh, that you know about the issue there, and then in southern China, if there are colleagues here, the studies took place in Guizhou province, and from people who consume rice. So you can see that the arsenic concentration does not just affect when it's in water, but also when it's in food. Where does arsenic occur? Arsenic is a chemical element that is found geogenically in rocks, minerals, such as arsenopyrite. It can occur as macroscopic. You can see it in a hand specimen, or sometimes microscopic. For example, in the case of coal in China, where microscopic arsenic was found in pyrite, and when people burn coal, they get contaminated and it contributes to their health impacts. Why this one is not working? Come on. Huh? Where must I? Okay, here it's working. So from a geological point of view, in Africa, we have evidence of high concentrations of arsenic in a number of countries. For example, on this map here, which is published in 2015, the dark gray areas are more than 50%. All these dark gray areas, they show concentrations in groundwater more than 50%, and then the rest either not studied or shows low concentrations. So in addition to this study in 2015, I looked into other more recent studies, for example, or just other studies in different parts of Africa, including Morocco in North Africa, Ethiopia in East Africa, Botswana, and South Africa. And these regions, they show, for example, in Morocco, up to 199 microgram per liter. You can just imagine. And then in Ethiopia, 278 micrograms. In South Africa, 253. I'm just giving some random examples. And in Botswana, 188% of microgram per liter in water. And from a health point of view, when I look at the reports of World Health Organization, I can see that the cardiovascular diseases are picking up in the 4 countries that have high concentrations of arsenic, followed by cancer, followed by diabetes and chronic respiratory diseases. So you can see the same trend occurs again. Of course, I'm connecting dots that are far away from each other, but this is just to give you an idea that there might be a connection worth investigating. Now, the other elements that I would like to illustrate briefly is fluoride. Fluoride is an essential element. It means that we need it for our health. But in the right dose, as I said earlier, it is beneficial if it occurs between 0.5 and 1.5 milligram per liter, and it is detrimental if it's below or beyond these values. We know from classic studies that too much of fluoride or less causes dental or skeleton fluorosis. However, there is growing evidence again that fluoride affects or causes more serious diseases under the NCDs group, including cardiovascular disease, even cancer. Of course, it is not a direct implication. When fluoride causes fluorosis, which is damage to the bones, with time that might contribute to the occurrence of bone cancer, indirectly. And then diabetes and diabetic microvascular complications. So, where does fluoride occur? In volcanic eruptions, through degassing of hydrogen, fluoride, and magmatic, which goes into the air. You know that the East African Rift Valley is tectonically active, therefore this issue can occur very common. Then in volcanic and igneous rocks, through water-rock interaction and withering into soil. So it's not just in water, it's also in soil and in Yes, I'm nearly done. All right, now looking at the concentrations of fluoride in the literature, in the East African Rift Valley in Kenya, we have 72% milligram per liter. In Morocco, 6.5, and in South Africa, 38. You can see that it's beyond 1.5. I'm only talking about the excess. Again, looking at the health issues in the cardiovascular diseases in Morocco are the leading cause, followed by South Africa and then Kenya. So, looking at the statistic of cardiovascular diseases, in 2019, these 1 million deaths were attributed to cardiovascular diseases in sub-Saharan Africa. 30% of all these deaths in Africa, they occur in Africa. Then diabetes, the same thing. 2.5 million in 2000, 24% million, in 2024, and there is an estimation that it can go up to 60 million in 2050. I'm not saying that fluoride is the main cause for diabetes, okay? Please don't take me wrong. All what I'm saying is there is growing evidence that the excess of this element can cause, and therefore can contribute to this issue. So then, could arsenic and fluoride in Africa contributing factors to the high percentage of NCDs and deaths in Africa? Let me finish with, how many minutes I have? 2, 5? 2 minutes. Oh my goodness, give me 5, please. Thank you. All right. From geoenvironmental issues and consequences is the certain non-communicable diseases, like what we mentioned earlier, fluorosis, thyroid dysfunction, thyroid disorder, or iodine deficiency disorder, they don't cause death. What do? They cause physical disability. And if people are disabled, they cannot contribute to social and work. They are prohibited from work. They can't contribute. This has impact on serious financial and emotional status of the population. And if this occurs, it enhances poverty. And if the poverty enhances, then it creates inequality. So it's a chain that starts from the well-being and ends by inequalities. And this is now causing serious impact on the socio-economic development and therefore SDGs. So, how can medical geology contribute to this? Through assuring or ensuring good health and promotion of well-being, because good health enables people to face various challenges in different social and economic environments, and if people are in good health, they contribute to reduction of poverty and inequalities, and then, of course, reduction of hunger. So all is around these 3 SDGs here. They are controlled by the good health. Unless we solve the problem of health, we cannot achieve, or we cannot progress with the achievement of the rest of SDGs. Few words about the other SDGs. How can medical geology contribute to them? Let me focus on education. In 2025, I believe that education is not just the right to go to school. I think it is the right to knowledge integration. Students need to know about geology is not just about mining. Geology is about health, so changing the perception. These contribute indirectly to gender equality. a lot of females cannot continue with geology studies because they think it's all about mining. But the moment you introduce health into the discipline, it changes the perception. And I can show you a perfect example. At the moment, I have 3 PhD students who are female, mothers, single mothers, with 1 male. It has never happened before I engage in medical geology. So this is a perfect example that once you introduce health into the discipline, it changes the perception, and females are no longer scared to embark in these studies. These are 3 master students. One of them is a female. This is also to show you that what do I do to achieve SDGs? I educate a young generation of students in Africa to learn, to understand the impact of their environments on their health. And this type of training requires international collaboration, which is aligned with SDG number 17, collaboration. You have to collaborate with people if you want to achieve this training. And then finally, a big thank you from my group at the University of Johannesburg. And thank you for your patience. I'm sorry that I took more time. Thank you.
Thank you very much, Professor Mori, for that presentation on the role of medical geology in achieving sustainable development goals in Africa. At this moment, colleagues, I can see there is a hand up. I'm not sure whether it's a question or it's a comment, because what we wanted to do in the interest of time, without blocking you, I'll come back to you, is that we may have about 4 or 5 instead of 6 presentations. That's why I was generous at the time, so that she can also cover. But what we want to do in order to expedite the process, we wanted to have maybe all the presentations, then people can capture questions, then we can have the last session or segment dedicated to question and answer, so that even if it drags into lunch, we will not shortchange anyone who is supposed to be presenting. So I'm not sure with that information if you still want to proceed, because maybe there may be something that you may want to highlight. Okay, thank you.
Okay. Thank you very much, Thomas, for this conclusion to this talk. Our next speaker now will be Professor Thomas Marambanyika, sorry if I don't pronounce it properly, who is going to talk about towards effective wetland governance system in Southern Africa, experiences and future directions. Please, the floor is yours. You have 15 minutes, I think. And we proceed with the questions, as Prof. Thomas mentioned earlier, at the end of the session. Thank you. Do you need this?
No, I can. Thank you very much, Prof, for the introduction. You know, being a chair to be a presenter, that transition. But anyway, I will manage. As already been introduced, my name is Thomas Marambanyika from Midland State University in Zimbabwe. And my presentation will be really on issues of governance when it comes to wetlands in Southern Africa, whereby I'm going to present more on some analysis which I have done to look at how governance systems are actually impacting on wetland management and what needs to be done in order to improve that. Okay. Now, maybe my presentation will be very brief. I can see the screens are stable here. Maybe I will refer to that one. Basically, I will try to give an introduction, which is sort of a background in terms of the context under which the presentation is going to be sort of molded. Then I'll also highlight some of the drivers of wetland degradation and loss in Southern Africa, which actually informs or are being governed by the different regulations that are there. Then I'll also give a brief analysis of the wetland regulations, in this case looking at the policies and legislation in selected countries in Southern Africa. Then at the end, we propose a wetland governance framework that we feel that can be used in light of the analysis that I've done in Southern Africa. So, if you are, for those of you who follow discussions actually in wetlands, you find that it is actually a major issue when it comes to wetland degradation and loss, not only in Africa, but world over. And you find that there is a lot of discussion which has been happening in terms of looking at the status of wetlands and also think about what governance can be done. And if you look at statistics, they show that wetlands are disappearing at 3 times the rate of forests. I know most people are very much aware of statistics on forests, but not on wetlands. And in terms of the actual numbers, find that on average, there is an annual loss of about 0.52% of wetlands, that is since 1970. So it's really scary, and for some, if you go back to 1900, you may talk about 60% or more of the wetlands been lost globally. And in terms of the actual numbers, you can find that since 1970, we have lost almost 22% of the wetlands, that's globally. So again, that's another challenge we are having. Then despite these losses that I've actually highlighted, you find that wetlands, they provide numerous ecosystem services which are sustaining the society. And today people also are talking about climate change, whereby they are also involved even in climate regulation. They are also involved in flood controls. They are also involved in water security. They can also even contribute to issues of food. So you find that for the earth, for us to survive on earth, we really need these wetlands to be with us. Yes, I can acknowledge that a lot of research has been done, looking at the status of wetlands, looking at the health of the wetland, but it is also clear that we need to interrogate the social processes that are behind wetland use management, because these also determine the rate at which wetlands are being degraded through different uses that they're being exposed to. And when we talk about social processes, key aspects that may come out or which may include part of the discussion, we have got cultural issues, we have got also traditional issues, legal aspects, policy aspects, and institutional arrangements. All these come into realization when we are talking about wetland management from a social perspective. And you find that research has shown that these social processes have got different impacts in different societies where wetlands are actually found. Now, what do we need to do? What is important is that we need to effectively manage the wetlands so that we can deal with the rate of loss, which I have already alluded to. And what is clear, if you look at the global wetlands outlook, which was published this year, is that the remaining 1.4 billion hectares of wetlands will deliver about 39 trillion annually in terms of ecosystem goods and services. So in other words, for us to realize that monetary value, we need to start thinking about how can we strengthen wetland management. So what is key is now to think about the strategies that can be employed in order to achieve that. And even at Conference of Parties, which was held just the previous month, one of the key resolutions was on wetland conservation and restoration. And the aim is to halt and reverse wetland loss by 2034. And one of the key pillars that were actually identified in order to achieve that is the need to improve governance. So, what do you mean by governance, and what are the key aspects that are talked about when you look at governance? You find that in governance, we really are concerned about even the institutions that are involved, the legislations that are involved, the policies that are involved, the strategies that are put in place. And therefore, it is important for us to keep on analyzing the policy gaps that we may have in different societies, because the society is evolving, and you find that policies sometimes tend to address contemporary or certain issues that may happen at a certain time. So I feel that there was need for us to really also analyze, to look at now, what are the policy gaps, what are the institutional gaps, what are the shortcomings in the strategies that are in Southern Africa in as far as safeguarding wetland ecosystem is concerned. So in Southern Africa, the focus was basically on about 5 countries, that is Botswana, Namibia, South Africa, Zambia, and Zimbabwe, which are almost sharing some of the transboundary river basins, which include Okavango, Limpopo, and Zambezi. Maybe to just highlight some of the key drivers that I picked in as far as wetland degradation loss is concerned, you find that one of the major is to do with the crop cultivation. I think you know that most of the people in Southern Africa, they really rely on agriculture and also especially crop cultivation. And you find that most of those activities are also being done in wetlands with negative impacts in most cases. Then we can also talk about urbanization or urban settlement expansion, which is happening in different countries, infrastructural development, pollution from agrochemicals and mining, invasive species, poor economic performance and rising poverty because people need to survive. And you find that also because of climate change and other issues, most of the wetlands, that's where you can have moisture for them to have almost all year round agriculture. Then you can also talk about poor urban service delivery, whereby you find that if it comes, for example, to sewer management, there is a challenge. Now we even have some wetlands which have been developed from sewage, which is actually coming from our urban societies. Then, of course, climate change is also one of the key elements. Now, what we've done in brief is also to look at the policy positions in countries in Southern Africa. And I want to acknowledge that there is some work that has also been done there, which I had also to improve and adapt to look at what is the current situation. So in terms of policies, what is coming out clearly is that countries like Botswana, they do have a national wetland policy and strategy, which they call a draft of 1999, but they are actually using that one also to assist managing wetlands. And one thing in terms of implications that I picked, that the framework provides for national wetland management planning. So in other words, it provides for a well-coordinated strategy in as far as management of the wetlands is concerned. And it also encourages active support and conflict resolution. And at the core of the support, there is also public participation that is also being promoted. Then you can also look at Namibia in terms of they do have what we call a draft wetland policy of 2004, and it has been a draft for, I think, for almost close to 2 decades. And some of the implications that you find that there is poor and weak sectoral coordination between the stakeholders involved in wetland use and management. And sometimes there is also failure to recognize wetland policy problems and how to counteract those problems. Why? Because there is no systematic approach in terms of how to achieve things. Then if you look at South Africa as a country, South Africa does not have a standalone wetland policy. What they have is that the policy is spread across different sectors, which includes water, biodiversity, environment, etc. So that's how they manage to frame it in as far as their national agenda is concerned, because they feel that it is wetlands are actually governed by a number of areas, including environment. So what is the challenge with that? You find that there is some bit of poor implementation of the law or the policies, which is largely rooted in inefficient resources and capacity. Then there are also weaknesses in the structures and practice of the corporate government, which is actually used in South Africa, whereby I find that there may be some fragmented and uncoordinated approaches. Sorry, this one is playing a bit here. Across different government spheres which hinder effective implementation. So you find that that also leads into some bit of overlaps and some gaps when it comes to implementation of the policies. And you know, when something is being done by many institutions, there is bound also to be lack of accountability because people are reluctant to say someone should shoulder the blame. Then in Zambia, they've got a wetland policy of 2018, which also highlights how more sectoral participation can be coordinated in that particular country. Then Zimbabwe, of course, also has a policy of 2022, which has also improved sectoral coordination and implementation of wetland laws. Then, based on that policy, they managed also to develop wetland management guidelines and also came up with a national wetlands master plan. Then, in terms of legislation, just maybe a quick rundown. Botswana, you've got those laws, of course, not specific for wetlands, but those actual touches on how wetlands can actually be managed. So the implication is that there is some bit of fragmentation in the piece of legislation, and you may find that also there is ineffective and expensive administrative system with overlaps, because we are trying to deal with main institutions that actually manage wetlands. Then in Namibia, of course, they've got also laws which touches on water, environment, and even their constitution. And, but of course, like I've said, you find that in terms of coordination and monitoring, is something that also needs to be improved. South Africa, of course, also those listed, they are actually touching on laws. And of course, like I've talked already about poor implementation, we also sometimes have some conflicting interpretations of provisions of the law and policies, in some cases also inadequate finance to wetland management and institutional capacitation. Then Zambia, there is some bit of harm there, although there is need also maybe to reduce some sort of confusion or to improve awareness on what the law says so that it can be implemented effectively. Then in Zimbabwe, of course, those laws also, but the major challenge is also on the weaker penalties, which are undermining enforcement of the legal provisions and also competing interests, which are also threatening stability in terms of management of the wetlands. Maybe as I wrap up, I can see time is not on my side. That is a proposed wetland governance framework, which I have actually adapted from one of the work which I did with colleagues to look at what are the key issues, what needs to be done in order to ensure that there is effective governance of wetlands. At the core, you can see we have got the institutional environment, where we talk about the laws, policies, ICEES, and we also have the institutional arrangements, whereby we are talking about who is supposed to be involved, whereby largely you find that you have got state actors and non-state actors, and there are main non-state actors. So what is important is that when you want to effectively manage whatever wetlands, you need to understand the institutional environment, you need to understand the institutional arrangement in terms of the actors, and that should be discussed within the context of the causes and drivers of wetland loss, because these may be peculiar to different types of wetlands. So at the end of the day, if you use maybe a one-size-fits-all strategy, it may be actually difficult. So what I'm simply saying that for the different countries, they need to scan their environment, understand what are the causes, so that at the end of the day, they come up with appropriate institutional environment and institutional arrangements. And these normally actually influence the plans and strategies that are supposed to be put in place in order to ensure sustainability. And in this case, when we talk about sustainability, we also need not only to think about preserving the ecological integrity of the wetlands, but also need to think about the livelihoods of the people, because they are very important in as far as the use and management of those wetlands are concerned. Then, of course, we need also to think about the implementation mechanisms. And I always emphasize on wetland valuation scheme to say it's always important to periodically look at the value of the wetlands or the benefits of the wetlands to the community. Why? Because it is those values normally that can shape the management system in terms of the people's desire in as far as involvement in wetland conservation is concerned. And of course, the ultimate goal, issues to do with wise use of the wetlands and also increased human well-being. So you can see there is some bit of complexities in terms of how things should actually work on the ground, because in other words, you may find that the institutions may also fit into the outcome, and the outcome also fits into the institution, and that matrix can go like that. So, ladies and gentlemen, I think I've come to the end of my presentation. Thank you very much for your time. It was just an overview of the situation and the direction which I think we may need to take in as far as wetland governance is concerned in Southern Africa. Thank you.
Must I introduce the other speaker? I introduced the other speaker, this one. Thank you, Prof. Thomas, for this presentation and for keeping it on time. Thank you. As Prof. Thomas mentioned earlier, we keep the discussion at the end of the session. So now we call our next speaker, Prof. Angapan Sugati, Professor or Dr. Suganti. Is he here? You are here. Okay, please come. Thank you very much. Next, back, laser. 15 minutes. You have the clock there. Thank you.
Yeah, pleasant good morning to all. Vanakkam. I am Suganti from Tamil Nadu Agricultural University, Coimbatore, India. And I'm here to give the presentation of our research work on evaluation of lactic acid bacteria for accelerating the dissipation of insecticide residues in curry leaf, field study, and microbial degradation. So pesticides, they are important tool in pest management. Pesticides are important critical inputs for crop management. So pesticides are used to manage insect pests in several crops across the globe. However, when pesticides are used, they result in problems like residue, then insect resurgence, and insect resistance. Out of these three problems, residues in the environment, including soil, water, as the previous speaker said, in the wetland ecosystem, and the residues in the food are harmful in their, to the environment as well as to the safety of human beings. So these pesticide residues need to be tackled. So several techniques are developed for degrading these pesticide residues. We have focused on bioremediation using microbials for degrading the pesticides, and we focused on the management of pesticide residues in food crops. So the main objective of our study was to standardize and validate the method for reduction of insecticide residues in the selected lactic acid bacteria culture broth where it was cultured, and to standardize the method for detecting the residues in the model crop selected, that is curry leaf. The residues were extracted and analyzed using liquid chromatography mass spectrometry method. And the other objective was to study the impact of the selected lactic acid bacteria species, Lactobacillus pentosus and Lactococcus lactis, subspecies lactis, on the dissipation of the insecticide, the selected insecticide cyantraniliprole in the crop curry leaf. So moving on with the methodology. So we isolated lactic acid bacteria from the fruits and vegetables that were collected from the area where pesticides were used very intensively. So the homogenized substrate was inoculated in the MRS broth, and then it was incubated for 10 days. So then by serial dilution, the colony was purified, and then it was multiplied in the laboratory. And for storage, it was preserved in glycerol at minus 60 degrees centigrade until further use. Then we collected nearly 30 lactic acid bacteria. However, when they were tested for their efficacy in the laboratory studies, only 6 were found to be effective in reducing the pesticide residues. Right, I'll go ahead with this. Until that time, I will go ahead with this. Let him set.
Yeah, he's actually trying to fix it.
Fix it, so you have to use it like I did.
Okay.
Sorry for that.
Okay. Right, these lactic acid bacteria, which were identified for their degradation potential, were characterized both morphologically as well as by their biochemical characteristics, including the following parameters, including gram staining and catalase test. So these two lactic acid bacteria, Lactococcus lactis and Lactobacillus pentosus, proved effective in the laboratory condition. So all these residue degradation studies were conducted using the liquid chromatography system. We used Waters liquid chromatography mass spec system with a C18 column, and the mobile phase was water and acetonitrile. The flow rate was around 0.5 ml, and the samples for each sample were run for 10 minutes. And the MS condition were also optimized. The MRM transitions for the mass spectrometry identification and confirmation for the selected insecticide cyantraniliprole was 475 m by Z mass by charge ratio for the parent ion molecule, and 177 and 285.89 mass by charge ratio for the parent molecule. So with these parameters, we could identify the presence of cyantraniliprole residue in the broth as well as the curry leaf matrix. Once the broth was inoculated with the LAB culture, and when it was added with the test insecticide, so to see the degradation potential, we processed or extracted the broth matrix following the procedure. So here 10 ml of the broth, insecticide spiked broth, or the unknown broth matrix was extracted with acetonitrile solvent, and then the other interfering matters from the matrix was cleaned up using salts like magnesium sulfate, primary, secondary amine, and the samples were centrifuged, and final extract was taken, and it was injected in the liquid chromatography system. So these are the sequence of the steps which we followed. Similarly, for extraction of the test insecticide from the curry leaf matrix, around 5 gram of the homogenized leaf sample was taken. This was extracted with the selected solvent acetonitrile. Again, the sample was cleaned up from interfering matrices like pigments, other waxes and lipids using primary, secondary amine, magnesium sulfate, and graphitized carbon black. So here, additionally, we used graphitized carbon black to remove the pigments from the leaf matrix, which is a very important contaminant when we inject the samples in liquid chromatographic system. So finally, the samples after extraction and cleanup, they were injected in the liquid chromatography mass spectrometry system. So after developing a standard method, we started mass culturing the selected lactic acid bacteria in the laboratory for field application. So finally, 5% of the lactic acid bacteria that was multiplied in the laboratory was taken for field application in the curry leaf. Moving to the field experiment, the test insecticide, cyantraniliprole, 10.26% OD. This is the commercial formulation which is available in the market for use by any farmers in this crop. So here we selected this curry leaf crop because this is one of the crop where pesticide is intensively used, but there is no regulatory limit for the pesticides that are applied on this crop. This is also an important herb crop which is nutritious as well as it is used in many of the Indian cooking. So we took this as a model crop, and we selected this insecticide based on the survey conducted among the farmers. Though there is no recommendation, farmers were using this, so we selected this chemical. So this is the field of curry leaf. Cyantraniliprole, the test chemical, was applied at 2 doses. One at the recommended dose, the recommendation that is given for other crop, but not for curry leaf. And then the second dose is bit higher dose. So this was selected to simulate a worst case scenario wherein farmers, they go for higher dose. So at 2 doses, cyantraniliprole chemical was applied in the field, and the spraying was taken 40 days after pruning. So that there was good flush, green flush in the crop. Then after insecticidal spraying, the samples of curry leaves were collected at 0 day. It means 2 hours after spraying. And subsequently, the samples were collected at 1, 3, 5, 7, 10, 15, 30, 25, and 30 days after spraying. So then next to that, the lactic acid bacteria strains which proved effective in the laboratory, that is Lactobacillus pentosus and Lactococcus lactis, were sprayed at 5% concentration in the same curry leaf crop 1 day after taking up the pesticide spray. So we just want to give this gap to allow, not to compensate for the pest management by the cyantraniliprole. So this is an insecticide that is used targeting pest control in curry leaf. So we gave 1 day gap, and then the lactic acid bacteria was sprayed to test its efficacy against the chemical. So moving on to the results, so we developed the method for extracting the test insecticide from the broth matrix as well as from the leaf matrix. So then this standardized method was validated as per the criteria fixed by SANTE 2021 guidelines, that is developed by European Commission for analyzing pesticide residues in any food commodities. So the different criteria for validation, including linearity, that is to test the sensitivity of the instrument. We tested 5 different concentrations of cyantraniliprole starting from 0.01 to 0.1 ppm, and the instrument sensitivity varied as per the dose, and this was proved through the correlation coefficient value of 0.996 nearing 1. So the instrument was sensitive enough to detect the chemical. Then we validated the method using recovery and precision factors. So spiked curry leaf samples, the samples spiked with cyantraniliprole were processed as per the method we have standardized. They were injected, and we founded the recovery values between 70 to 120%, which is more acceptable as per the SANTE guidelines developed by European Union. So both for recovery of the cyantraniliprole from broth matrix as well as curry leaf matrix, the recovery was very good, and the precision was also acceptable, which is less than 20%. So we can see from the values that the recovery is more than 70%. So here you can see the linearity graph, which shows the instrument sensitivity, and then the chromatograms corresponding to different recovery samples. Then in the coming to the results that we have obtained through the laboratory studies. So first, the table shows the results obtained with Lactobacillus pentosus. Here we tested the broth at 4 different conditions. So first one is broth without dilution with the actual LAB culture, and then 10 times dilution of the broth, 50 times dilution, and 100 times dilution. So this different dilutions were followed just to ensure that the lactic acid bacteria is not utilizing the broth alone for their food, or to test whether they depend on the pesticides as a carbon source. So again, the insecticide degradation potential was tested at 3 intervals: at 0th day, that is within 6 to 8 hours after spiking the broth matrix with insecticide, and then 5 days after spiking the broth matrix with insecticide, and then on 10th day after spiking the broth matrix with the test insecticide cyantraniliprole. And here you can see that the degradation started from the first day, though it was very less, around 2%. On the 5th day and 10th day, we can see around 90% reduction of cyantraniliprole residues in the broth. So this proves that the lactic acid bacteria, though it utilized the MRS broth contents, it also used this or degraded these pesticides either by using the insecticide as carbon source or by producing some enzymes. So that is proved through the residue degradation, which was deducted using liquid chromatographic system. So on 5th day and 10th day itself, we can see 90% reduction of residues, that is cyantraniliprole residues, enhanced by this lactic acid bacteria. This is with Lactobacillus pentosus. And in the, again, Lactococcus lactis also proved effective in reducing or degrading the pesticide residue by around 98% after 10 days of spiking the broth matrix, which contained LAB. So this, again, this also proved effective in degrading cyantraniliprole residues, but comparatively Lactobacillus pentosus proved better than Lactococcus lactis in the laboratory condition. Then from our field experiment, we could see that when cyantraniliprole was applied on curry leaf, and when we collected the samples at different intervals, and when it was analyzed using liquid chromatography mass spectrometry system, the initial residue was around 0.12 ppm, and the pesticide residues, the initial deposit started degrading, and it reached below the quantification limit at around 30 days. So this was the condition with both the recommended dose, that is the first dose 43 gram active ingredient per hectare, and the second dose 54 gram active ingredient per hectare. So cyantraniliprole residues on curry leaf, it took around 25 days to degrade below the quantification limit. So there is no regulatory limit available for the residues of cyantraniliprole in curry leaf, so I couldn't correlate it with the regulatory limit. However, as a default, the MRL for any chemical is fixed as 0.01 ppm by European Union. So this, our deduction limit, our quantification limit is also 0.01. The residues reached below the quantification limit by around 30 days. So this is the case only when cyantraniliprole was applied on curry leaf. Next to this, when we applied the lactic acid bacteria, both Lactobacillus pentosus and Lactococcus lactis, they started degrading the pesticide, and around 60%, here you can see, this is the pointer is not working. So again, the samples were collected at 1, 3, 5, 7, 20, 25, and until 30 days. So around 60% degradation of the residues were observed on 25th day with Lactobacillus pentosus and Lactococcus lactis. So from this graph, you can see we have given a comparative graph here. So the first is Lactobacillus pentosus. Right. So from the first graph, from the upper part, we can see that when cyantraniliprole alone was applied, it took 30 days for the insecticide residue to degrade. But when lactic acid bacteria was applied after the insecticide spray, the residues degraded within 25 days. That is 5 days earlier to the pesticide spray. The residues degraded. This was the case observed with Lactobacillus pentosus and Lactococcus lactis at the lowest dose, 43 gram active ingredient per hectare. However, at 54 gram active ingredient per hectare, Lactobacillus pentosus advanced the degradation of pesticide 5 days earlier, while Lactococcus lactis was similar with or without the LAB. So from this data, we can infer that the pre-harvest interval that is determined for cyantraniliprole residues in curry leaf was around 20 days, while it was only 15 to 16 days when LAB, that is lactic acid bacteria, was applied. So all this waiting period were calculated following the standard protocol. So whenever cyantraniliprole alone is applied, a farmer has to wait for until 20 days to get a residue-free product. But when cyantraniliprole application is followed by application of LAB, the produce can be harvested within 15 to 16 days with residues that cause less risk to human beings. This is what the pre-harvest interval it will indicate. So that is the time period until which the farmer has to wait to harvest the produce after application of pesticides. So cyantraniliprole alone is applied, he has to wait for 20 days to harvest the produce to ensure food safety to the consumers. But when LAB is applied after insecticide application, the produce can be harvested 5 days earlier, so that we can ensure the safety to the consumers. So moving on with the discussion, these LAB strains which are selective to this chemical were found effective in degrading the residues regardless of the concentration. We have tried two concentrations, 1% and 5%. Both the concentrations proved effective in degrading the residues. So culturing the lactic acid bacteria in the broth for 48 hours, it ensured the accumulation of the readily available enzymes that were produced by the bacteria. So like when the LAB was cultured in the laboratory and when it was taken to the field for spraying, on the first day itself we could see around 10 to 20% degradation of the residues. So this proves that these bacteria in storage, they have produced the enzymes that were able to degrade the pesticides. So these enzymes, and we also did the enzyme profiling for this bacteria, and we found that hydrolases, peroxidases, and GSTs, that is glutathione S transferases, were the major enzymes produced by this bacteria, which could have helped this bacteria in degrading the pesticides. So around 34 to 40% degradation of the residue was observed within 8 hours after application of the lactic acid bacteria. So the residues were reduced to below the quantification limit or below the regulatory limit at least 5 days earlier than the positive control. So these sprays could help advance the pre-harvest interval to be observed by the farmers or the end users for getting any residue-free produce. So to conclude, I could say that this study demonstrated the effectiveness of the two selective lactic acid bacteria, Lactobacillus pentosus and Lactococcus lactis, in degrading the pesticide residue, so which offers a potential bioremediation strategy. So this could help reduce the residues in the environmental matrix, including soil, water, as well as the food matrix. So this underscores the potential of using the lactic acid bacteria that is specific, which specific to the chemical or specific to the environment, as a very eco-friendly solution for managing the residues in the food as well as in the environmental matrices, including soil and water. See, these LABs, they can survive in the leaf surface and they can also sustain in the rhizosphere of the soil. So these lactic acid bacteria, which are also probiotic in nature, can also be exploited for managing the pesticides residues in the soil. So here we have tested only the insecticide, but this could also be scaled up for degrading the residues, herbicide residues in the soil, as well as the insecticide and fungicide residues in the food matrices. So as a future scope, we can explore or scale up these lactic acid bacteria for other chemicals and other crops. And we can also scale up the practical application of LAB in cases like drone application. So this is a technique which is fast coming up. Here, these LABs can be developed as formulations and they can be applied through drone, or else in future we can also develop pre-mix combinations of pesticides and LABs if they are compatible, and this can be advocated to farmers. So pesticides without compromising for pest management can be degraded by these LABs. So thank you for patiently listening to me. Thank you very much.
Sit here for questions. Yeah. Please. We will have questions like that.
Thank you very much for the presentation, Doc. As I've said at the beginning, just hold on to your questions, then we can have them at the end. Can I move on to the next presenter? I'm not sure if she is around. It's a he, Mr. Mandlel Love, who is supposed to present on a study of emerging contaminants in surface water and groundwater of the Greater Durban region, a non-targeted screening approach. Is Mr. Love around? If he's not, can we move on to the last presenter? Then after that, we can have question and answer. That's Mrs. Molele. I cannot pronounce the name correctly. Molef. Is she here? She's going to present on a literature review on air quality impacts of post-harvest sugarcane burning using remote sensing. The floor is yours, Mrs. Molef. So for time, you look at the screen to be dropping the time up to 0.
Okay. Thank you very much. Welcome, everybody, to my very first conference presentation. My name is Molebohe Molefe, and I am a junior remote sensing scientist from SANSA, and I am going to present on my systematic literature review on the impacts of pre-harvest burning using remote sensing. This literature review forms part of my MSc project, which I'll be doing at UKZN, supervised by Dr. Lerato Shikwambana, as well as Dr. Sfiso Kulu. Sorry. sorry. There we go. So these are some of the contents that I'm going to cover in this literature review. I'm going to give you a brief background of the study all in itself, as well as the objectives and the relevance of the systematic literature review, followed by the methods that I used and the results, as well as the gaps that I noticed in the literature and the limitations when it comes to this type of literature review. Okay, so South Africa has a very big sugarcane industry, and it's in the top 15 out of 120 countries. It contributes about 15% of the total gross value of agricultural production in the country, producing over 20 million tons per annum and employing over 335,000 people. So sugarcane in the country is predominantly found in KZN and in Mpumalanga province, and this is due to their subtropical climate. And the harvest period is usually about 8 months between April and December, using manual or mechanical methods. In South Africa, the sugarcane is harvested mostly using manual methods, and manual sugarcane harvesting involves pre-burning of the sugarcane. And then the remaining 10%, they use mechanical methods which involve the use of machinery. Manual sugarcane harvesting leads to environmental impacts such as land degradation, water pollution, as well as air pollution. And then it also leads to health impacts such as respiratory diseases. The objectives of this literature review are two of them. So the first one involves performing a bibliometric analysis to identify publication trends, as well as to, the distribution of the remote sensing-based air quality and sugarcane biomass burning studies, as well as the associated health risks. The second objective of the study is to identify gaps as well as emerging trends in the literature and to propose future areas of research. Why is this type of study relevant? It is relevant because it synthesizes existing research on sugarcane biomass burning, as well as it quantifies and identifies gaps in the air quality and biomass burning topic. It helps us to guide policy and planning within a South African context. So the methods I used in this literature review, there's 3 of them. The first one is data acquisition through Scopus, and the second one is data filtering using the Prisma method, and then the third one involves analysis and visualization through Python, QGIS, and VOS Viewer. So Scopus is a comprehensive database that helps researchers to find relevant literature, to track emerging trends, and to identify top experts in their topic of interest. It has about 19.5 million authors, enabling users to analyze and to analyze research impacts and collaborations. So the following table is basically a breakdown of the search criteria I used. I searched using 3 steps, and I was able to filter the number of articles from 753 all the way to 291 using keywords such as biomass burning, tropomi, PM25, atmospheric pollution, and the time period for my study was about 10 years, which is between 2015 and 2026. The Prisma method is basically a breakdown of the selection process of the articles that I used in the overall literature review. And like I mentioned before, I started off with 753 articles, and 465 of them were eliminated using the automated tools in Scopus, leaving me with 291 articles, which I screened, and I found that 196 of them did not meet the criteria in terms of the topic I'm interested in. So this left me with 95 articles, and about 3 of them could not be retrieved due to subscription limitations. So this overall left me with 92 articles, which I then used to perform the analysis and interpretation. So we're moving on to results. So I downloaded a CSV file containing the 92 data sets, and I visualized it in Python, and this was one of the graphs that I was able to produce, which shows annual trends in research articles between 2015 and 2025. And it shows a gradual increase of publications, starting with 4 in 2015, peaking at 14 in 2021, and 15 in 2023. However, it also shows us that there were times where the publication numbers dropped in 2022, 2024, and 2025. I would say overall, the general trend that we're seeing here is that there's a growing interest in remote sensing-based air quality and biomass burning publications. The second graph that I was able to produce, it shows trends in journal publications. And the first thing I did here was group the journal publications into themes, which are air quality and climate change, environmental, machine learning, and remote sensing. And as we can see, environmental makes up the majority of the types of publications that are out there, followed by remote sensing, and then air quality and machine learning are coming in as emerging themes. From the same graph, we can see that the atmospheric chemistry and physics journal has the highest number of publications, I think approximately 13.5, followed by the atmosphere journal at about 11 publications. And then we have the remote sensing journal, which has about 7 or 8 publications in the study. Okay, so I then created a choropleth map, which showed the spatial distribution of publications globally. And from this data set, we can see that the USA has a high number of publications with 36, followed by China with 13, followed by France with 5. However, South Africa, in red, has only 2 in this literature review, right? It shows that there's limited research when it comes to the application of remote sensing in monitoring biomass burning, as well as there is a need for such studies in the country or more collaboration with people in the US or China, for instance. The last diagram that I produced was a network diagram, and it shows the interrelationships between the keywords and the publications. So this network diagram, it groups publications into clusters or keywords into clusters. And the first cluster we have, which is the orange one, it focuses on terms like air quality and black carbon, and it highlights core environmental or air quality concerns in this specific topic. And then cluster 2, which is green, which contains keywords like biomass, burning, burned area. This theme, it focuses on agricultural emissions and their impact. It is very closely related to remote sensing and air quality. It indicates that remote sensing is a useful tool when studying air pollution. Cluster 3, the blue one, remote sensing. It has terms like remote sensing, satellite observations, Sentinel, and LiDAR, which are key methods we use in remote sensing to study and research air quality and biomass. Cluster 4, which includes terms like the atmosphere, atmospheric composition, and emission. It represents the scientific field that studies the physical and chemical processes occurring in the atmosphere. And then cluster 5, which is the blue one at the top, This cluster directly relates to the broader remote sensing and air quality themes. It focuses more on the types of instruments we use to study and monitor the atmosphere. And then cluster 6, which is in yellow, has terms like CAMS and MIRROR, which are used, or they provide data sets for models, and they are used for analyzing and forecasting. And then the last cluster, which is number 7 in purple, it contains terms like particulate matter, health assessments, and aerosol optical depth, and it directly connects air pollution to health impacts. When it comes to the gaps that I've seen so far, I would say the studies have limited amount of socio-economic data, and they are also seasonal. So there isn't continuous monitoring of air pollution within the agricultural sector. And then the other gap is health impacts. They are always inferred, they're not necessarily measured, which is a gap that I hope to exploit. In terms of limitations of the actual systematic literature review, it was time-consuming and it required careful screening so that I don't end up with the wrong results. And then there's also subscription requirements. So you might obtain a list of journal articles, but you might not necessarily have access to them because there are limitations. And then the last one, it is prone to publication bias, and you rely on the quality of the studies that are included in the data you have, so it can skew your results. Thank you very much.
Is it the last? Thank you very much for your excellent presentation. Given that this is the last speaker, so now we open the floor for discussion, questions, answers about all the topics that you heard this morning. There is one question there. We take one by one, and then, yes, please. Yes, that side.
Thank you very much, session chairs. My name is Melusi Sibanda from the University of Zululand, Department of Agriculture. Did you say I should ask one question at a time?
Sorry?
Can I ask one question at a time, or can I ask all of them? I've got a number of questions, comments.
Okay, you can just ask and we'll see how far we can go.
Okay, thank you very much. To the first study on medical geology, I just want to check how prevalent is food contamination by those elements that you indicated, arsenic, fluoride. I think you said the source was volcanic eruptions and other sources. I want to check how prevalent is that on food contamination, say for instance in South Africa. And maybe do you have a map also that may show maybe the hotspots of those food contamination? What recommendations do you have on agriculture, say on water quality, irrigation, soils, etc.? That's to the first speaker. Can I carry on? Okay.
Just go yeah, okay, it's working. I think it's better to ask speaker by speaker, otherwise we get confused. So I assume this question is for me. I'm sorry, I'm not sure I understood the question. It's about food.
On food contamination, yes. I think you mentioned arsenic and fluoride. On food contamination.
Food contamination by arsenic and fluoride. What is the
Yes.
question?
The question is how prevalent is that, let's say for example in South Africa, and maybe do you have a map, maybe that shows those hotspots, and probably what recommendations do you have maybe on agriculture, water quality, irrigation, soils, etc.?
I'm not sure I got it, but I try. Okay, the two examples I mentioned about arsenic and fluoride, I did not specifically relate them to food. They were just general examples. If I understood your question, I'm sorry, I think I did not get it right. Maybe you can come closer to me.
No, it's fine.
Or
Maybe we'll talk later.
Yeah, I'm sorry, I didn't get it.
All right, thanks.
We can then discuss it later because
Okay.
I'm not sure I got the question.
Okay. If I may proceed to this co-chair, the study on wetland governance. I just want to check the approach that you took for the review. Did you review all existing policies around wetlands or legislation documents on those selected countries? I didn't quite get the approach. And then also you mentioned agriculture as a contributor to wetland loss. Could you maybe elaborate further on that one?
I think you've got two issues. The first one is on the approach. Like I said, it was actually a literature review of largely the existing policies and laws in those countries. So I confined those results from the literature that I managed to get and also analyze, which largely speaks to almost literature to the recent years in terms of what is happening in the different countries. Then, of course, if there are some gaps, those are for further engagement, but largely that was the sort of approach, to look at what is the current status in as far as literature is concerned on the different countries which I have selected. Then the second one is on what?
The second one was on agriculture. Maybe if you could elaborate more.
Okay. On agriculture, I think there are a lot of studies which you see which have tried to look at different farming methods and how they've been affecting the wetland health. For example, I've also done some works in that area, in that space, whereby you may see that maybe when it comes to agriculture, there are different farming methods which are being implemented in different countries whose outcomes are different in terms of how they are affecting the wetland status in terms of the hydrology, in terms of the soil quality, in terms of the vegetation and so forth. So what I picked most, or what I can say most in Africa, is that you find that most of the methods, some of the methods which are being used, they actually result in depletion of soil moisture in those wetlands. Like, for example, if you go to some wetlands in Zimbabwe, there's been diversion of water to increase the area under agriculture, and sometimes the type of crops that are used also, they've been actually affecting the soil moisture, resulting in those wetlands actually are drying. So it depends now in terms of the types of crops, sometimes it depends on the method which is being used for cultivation, so the outcomes are different. And also remember, wetlands by their nature, they're also different in terms of their hydrogeomorphic characteristics. So what does that mean? It means that a method that may affect, maybe for example, an unchanneled valley bottom may not affect a channeled valley bottom or a floodplain because of the differences in terms of their setups. So that is something which you also need to understand in terms of the impact, to really understand also the type of wetland, the methods which are being used, the crops which are being grown, and the number of variables. Then you find that the outcome may also be different. But overall, you find that degradation is actually attributed to agriculture.
Thank you. My last question or comment on the last speaker on pre-harvest burning of sugarcane. You used one database, Scopus, and also in your limitations, you mentioned access issues. Did you consider perhaps open access databases? And also maybe you didn't elaborate much on your inclusion and exclusion criteria. And also you noted a decrease in recent years in the publications. Do you perhaps maybe have a reason for that, the trend why it was declining if you look at 24, 25. And maybe also in your bibliometric analysis, did you perhaps consider the affiliations or institutions that were publishing those studies? It could be nice also to see that impact. Thank you.
Yo, so many questions. The first one, I think you asked me about the database. So currently I've only used Scopus, but the literature review is ongoing. So I will add another database like maybe Web of Science. And then in terms of affiliations, no, I didn't consider the affiliations, even though they are part of the data sets that I pulled. So I don't know if you want me to have like a representation of the affiliations to see how they are distributed in the research. Okay. I forgot the other two questions in the middle.
The other one was around the decrease in publications. If you look at that trend, 23, 24, 25, there seemed to be a decrease. What could be the reason for that decrease in that research area?
Okay, I wanted to shy away from speculation, but I think for 2022, I might attribute it to backlog from COVID, but I still need to read further to find out what the cause might have been. And another factor I think could be the wait times between publications. It does take a long time for some people to be published. So I think that might be one of the reasons why. Yeah. Okay, thank you.
Thank you.
Shall I? Yeah.
Yes, please.
So I have a few questions for the third presenter, Dr. Sugandhi. And I would like to just know what was the rationale behind looking specifically for lactic acid bacteria on degradation of the chosen pesticide?
Yeah, there are many other bacteria and fungi which were found to degrade pesticide residues. Here, see, on one side we are focusing on degrading the pesticide residues to safeguard the environment, and on the other side, when the food produce goes to the consumers, we need to ensure the food safety as well as quality. So we need to give the food commodity free of residues. At the same time, when a bacteria or any microorganism is advocated for degrading the pesticide, it should not be harmful or it should not cause any risk to the human health. So we focused on selecting lactic acid bacteria which are more probiotic. Even if some residues of this lactic acid bacteria is left on the food commodity, it should not be, it will not cause any harm to the human beings. So that is the rationale behind selecting specifically lactic acid bacteria for degrading pesticide residues in food commodity. So to ensure food safety as well as quality.
Okay. So the actual concern why I was asking that question is there are now recent reports on the excess use of lactic acid bacteria and its effect on digestive system. So that is what the reason behind I asked that question. And have you worked on the economics as now the farmers has to spray lactic acid bacteria also, no?
Yeah,
so,
right, sir.
So have you worked on the economics on that?
So initially we have done the laboratory study and then we took it for field study. But though it is economically cheap, we need to develop a formulation that is easy for application from the farmer side. So now we have started focusing on developing formulation with increased shelf life, and also we are trying to explore the enzymes that are produced by this lactic acid bacteria, so which can be produced in large scale, industry scale, and then it can be provided to the end users at cheaper cost.
Thank you. And are you investigating on the metabolic pathway? Because people now are interested on understanding the degraded, the fate of the particular contaminant, because at times there are the metabolites which are more toxic than the actual contaminant. So are you investigating on the metabolic pathway?
Yeah, here we have selected only cyantraniliprole. The parent compound is only toxic and its metabolic product is not toxic. But there are several pesticides where their metabolites are more toxic than the parent compound. So this study will also be scaled up to other chemicals. So in future we will be focusing, if the metabolite is toxic, then we will look into the degradation potential of the LAB against the toxic metabolite too.
Thank you.
Thank you. Thank you very much. Any more questions? Elena, please, let's try to make our questions a little bit quick and then further discussion after, because we are eating time from the eating time.
From lunch. I only have one question. Ms. Molefe, well done for your first presentation. Really, congratulations. And then Professor Thomas, my question to you is, you focused on the Okavango, the Zambezi, and the Limpopo rivers. Why did you include Mozambique? Because the Limpopo and the Zambezi River flow through large expanses of Mozambique, and it's very flat, a lot of wetlands. Why did you exclude that?
Thank you. I think your question is, if I get it well, it's around the selection of the transboundary river basins. Why Limpopo, why Okavango, and why Zambezi?
No. Why did you exclude Mozambique?
Exclude Mozambique. Okay. Yeah, it was mainly to do with one, availability of data, and the issue of also language, some of the publications in Portuguese. Yeah? So it was a bit challenging because I'm more conversant with English and some local languages in my home country, so it becomes a bit of a challenge. But it's a gap that can be explored maybe with some bit of collaborations with people from that country, so that we can also enhance the database in terms of the representation in Southern Africa.
Yes, please. There's one question that side. One question, please. One. People are getting hungry.
The question is to the medical geology. So first time I'm hearing the talk on medical geology. So you have very well presented, and the narrative was very good. And the question is, so you have been talking about fluoride and its effects on the human, like bone cancer, so many things. How did you connect fluoride contamination with the diabetes?
Thank you very much for that very good question. Obviously, I do not connect. I did not do the research. What I presented today is sort of a review, okay? What I mentioned was based on epidemiologic and toxicologic studies. There are evidences where the certain chemical elements can contribute to diabetes disease. So that is why, from a geological point of view, we need to look into this aspect so that we can identify areas where there is excess of these kind of elements and do a health study so that we can confirm whether this is really happening or not. I did not do the research myself. So it's just, as I was saying, I was connecting dots that are not necessarily connected to each other from one single study. But through medical geology, that is what we are doing. We try to study an area from a geological point of view to health point of view. Or the postgraduate students that I mentioned, they do a holistic study from a geological to health study. And that is what is lacking we need to develop. Thank you. Yes, there is a question at the back there, the gentleman.
Thank you, Chair. I think let me just try to congratulate all the presenters today. I think their topics they are they are really interesting, especially from all the disciplines. But my questions are just two, from the first speaker and the last speaker. To the last speaker is just a comment. I think for the issue of access, if you can actually engage with your librarian, maybe she or he can be able to assist you with regards to get access to some of these articles that you are saying that you actually didn't get access to as a result of restrictions. So I think if I may request you to engage with your university librarian, she or he can actually be able to assist you. But to the first speaker, I just want to understand, I think you made mention of, when you were making a presentation of, I'm not sure whether it was geoforces or what, but I just want to understand whether what comes first between inequality and poverty in terms of your presentation. Thank you so much.
I am sorry, I could not understand. Is the question to me?
Yes.
Sorry. Can I ask you to rephrase it short, please?
I think on your last 2 pages of your presentation, you made a presentation to say that in terms of the, was it the geoforward what? In terms of what you're presentation, yeah, in terms of what you're presenting, you made mention, if I'm not mistaken, that poverty, that it causes poverty, then later on causes inequality. I just want to confirm.
Oh, how the health
yes.
Related to inequalities?
Yes, yes.
Oh, okay, all right.
Which one comes first? Is it inequality or poverty?
It's a circle.
Okay, thank you so much.
They are all interlinked, but obviously if we start from unhealthy population, then that causes poverty, and then it causes inequality, if you take it that way. If you see what I mean. So if someone is unhealthy, cannot work, is poor, and then he's down there comparing to someone who is healthy. Thank you. I don't know if it makes sense. Sorry, any other question? Or I think we give one last question if colleagues...
It's not a question, but a comment and encouragement to the last speaker on systematic review. I think you are in the right direction. Keep it up. Just stretch your arm further. Include the Web of Science. And for your information, nowadays many journals are publishing systematic reviews. So don't jitter. Just keep on keeping on, and you will go far. This is a very good approach. Thank you.
Thank you very much. Shall we take one more? One more question? Yes, and then maybe I think the gentleman was okay. Never mind. Ladies first. I'm the chair, so I'm a little bit, okay, please.
Oh, thank you so much for the opportunity. Even I just want to give a compliment to the last presenter. That was quite interesting, and I just want to know if you consider some of the meteorological parameters when you take all these data collection. So have you come across any papers related to that? I hope you got my question.
Also didn't
see, you are collecting the data. You can hear me, right? Is it clear?
We hear, but the problem is an echo around, so the questions don't reach us properly.
Something wrong with the mic, or maybe? Is it clear now?
Okay, you can try again.
Actually, this is a very interesting topic that she has given, the last presenter. I just want to give a compliment to her. I just want to know if you're collecting the daily meteorological parameters like rainfall, the wind speed, and many other things when you take the data for the air quality. So have you come across any papers related to that?
No, I'm going to consider literature on meteorological factors in the methodology, in the analysis part, because I want to look at how they actually affect air pollutants in the atmosphere. So for now, I'm just looking at the literature that is out there. Yeah.
Okay, thank you.
I think there is one. Okay, I think there is one person, we can't keep him. Just last one. Okay. Thank you, Chair.
Okay, thank you, Chair. My questions are on medical geology and also on wetlands. On medical geology, I just want to understand why there is an increase in NCD in Africa as compared to
Sorry,
NCD.
why?
Why there's an increase in NCDs in Africa as compared to other continents?
Why there is an increase in NCDs in Africa?
Yes.
Well, I think the question I asked is, could the geo-environment contribute, which hasn't been taken into account in the study of the causes of the diseases? I have shown examples of huge amount of arsenic in what just arsenic alone is enough to cause drama. So what about all the other elements that are toxic, which are occurring everywhere, and we don't know about their health implications? I'm also questioning, like you, unless we do studies like what I was telling to the colleague there, holistic studies where we combine health and geology together, we won't know what are the reasons for such increase in the statistics.
Okay.
I hope I answered your question.
No, you answered my question. My last question is on wetland to Prof, as director to Prof. Prof, you mentioned that if there is a degradation of wetland, there is a tendency of increase in flooding. I never understood why, what's the science behind that. If there is a degradation of wetland, it also increases flooding. I heard mentioning that.
Sorry, is the question still for me?
No, for Prof.
Dr. Thomas.
Yes.
Please, Thomas.
Sorry, I think you can come again because you are not very much audible in terms of clarity.
I heard you, if I heard you correct, mentioning that if there is a degradation or the depletion of wetland, there tend to be an increase in flooding. My question is that I don't understand like the science behind that. If you can maybe clarify that, Prof.
On that one, I think you can have bilateral discussion in terms of attenuation, yeah. How the wetland sort of absorbs water, maybe from the catchment, and normally in that process, they are sort of controlling the flow of water in a given area, which may actually result in flooding. But it's something which you can actually engage on to look at the dynamics in terms of attenuation to see how things happen there.
I think we have to go to eat. Can we continue the discussion after, during the coffee breaks and the lunch and so on? Because there's only 1 hour left for lunch. People seem to